I'm going to write a code for if the number is power of 2 or not. Check whether if the number is power of 2 or not, like 4, 8, and 16, 32 is all are power of 2. And I use three different approaches. I will use three different approaches for solving this problem. First one is the naive solution, which gives like quarter of log n, and rest all are will giving the order of 1 or order of set bits. Let's start it. Now, first of all, going to create one package name. Oh, sorry. Yeah, I'm going to create one package name com dot uh, second program dot java dot youtube. Now I'm going to create a class name check power of 2 or not. Check power of 2 or not. Now I'm going to import the package for reading and writing the input. Import java.util.star, which contains all the util packages. Now I'm going to write the main methods for calling the functions. Now I'm going to create the scanner class for reading the input from the user. New scanner system.in. Now, now taking one input as enter the number, integer number equal to h dot next int for reading the integer. And now I'm going to create the first one is naive solution, which gives order of log n actually. So naive solution, naive solution, private static, I'm I'm going to return the boolean type, boolean private static boolean is power of 2 by using naive solution. And I'm going to pass one integer variable name n and check whether the given number is power of 2 or not. For it, I'm going to check whether if the number is 0, then it's always return false. If number is 0, then always return false. And now I'm going to check the whole numbers which is divisible by 2 or not. While n not equal to 1 and not equal to 1, then I'm going to check if the number percent 2 not equal 0, then is obviously not divisible by 2, then simply return false. Then I'm going to decrease the number of by 2, this the set bit. Then if the number is not returning, that's why there is if the number n% equal to 0, then simply return true. Return true. Now counting the time complexity and space complexity of this algorithm is that the time complexity of this algorithm will give order of constant time, and here it will give the time complexity is order of total number of bits of this number, binary representation of this number, and order of 1. So time complexity is order of for this is order of constant time plus for this it is going to give the time complexity of order of binary representations of number itself and plus it gives order of constant. So obviously time complexity is order of binary representations of number, and the space complexity is nothing. It is uh, I did not use any any sets or any arrays or any list to store the values, so it's always going to give the space complex auxiliary space complexity as order of constant. Auxiliary space complexity is order of 1. That's it. Now calling the methods from the main class, see how it will give the time complexity. So mm, yeah, if is power of 2 is if it gives if it gives true, then that means it is the power of 2, else not power of 2, not power of 2. That's it. Now I'm going to run this program Java applications. Now I'm going to enter the number if 2. This is the power of 2. I'm going to give the number 3, not power of, sorry, not power of 2, simply. And 4 power of 2, and then if I enter 7, then it's not power of 2, and then 8 is a power of 2. Now I'm going to use Brian Kernighan's algorithms, which gives the time complexity of order of 1 actually. Uh, First one will give some. I'm using two or three. I'm two another two methods where first one will give the order of set speeds, and the next one will give the order of constant time complexity. That's it. Now I'm going to write the second one using Brian Cunningham's algorithm. BRI Brian Cunningham's algorithms, which actually gives the time complexity of order of set bits. Let's see what happens. Private static. I'm going to return the true or false. You can use anything return type like this. Is power of 2 Brian Cunningham's algorithms. And that's it. First, in Brian Cunningham's algorithm, if the set which returns 1, total number of set which is 1, then the number is power of 2, else not power of 2 actually. I'm going to give one examples also after reading the code. I'm showing one count variable. I'm declaring one count variable for counting the number of set bits. And now checking if the number is 0, then simply return false. And now again checking while loop 1 greater than 0, then I'm n and n minus 1 and n minus 1 and count plus. Every time uh, I'm going to do the one and end operation the number and number minus one, and if the count is going to one, then just return true, else return false, and return false. Like for this, I'm showing one example, showing example. No, if I'm going to give the number as 4. Now the binary representations of number 4 is 0 1 0, yeah, 1 2 4 8. Sorry, yeah, this is the binary representation 4 and plus, no, and the binary representation of n minus 1 is 3, like 0 0 1 1, like 1 plus 2 equal to 3. Now if I add this AND operation, it perform AND operations, then it will gives like 0 0 1 0 0 0 1 0 0 1 0. It is true for 4. If I use for another number like n equal to 4 6, if I use, yes, is 6, if I take 6, then it will be there is 1 1 extra, and then my 5 for 5 n minus 1, it is n minus 1, n minus 1 for n minus 1 is 5 1 and 4, 1 and 4 5, 1 2 4 1 and 4 5, and the end operation of this number will going to keep 0 0 0 1 1 1 0 0, going to, it is not 0, it is not 0, yeah, 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 it is not 0, then it will return false. Let's analyze the time complexity of these numbers. Time complexity of this number is going to be order of set bits, and since space complexity is order of 1 constant. Same I'm using the previous one. Is power of 2 by using Brian Carningham's algorithms. Let's see it will give the answer or not. Like if we give 8, then is the power of 2 correct? If we give 6, it is not the power of 2, both are giving the correct answer. Now I'm going to give the most efficient way by using the Brian Carningham's algorithms also. It is also by Brian Carningham's algorithms. Like Brian Carningham's algorithm. Algorithms also. Now, creating methods is part of the private static boolean is power of 2 prime Kernighan's efficient, and then I'm going to pass an integer value. Now it will gives only time complexity of order of 1 actually, just order of 1. If n equal to 0, simply return false, else now just return the simply one operations n into n and operations of n minus 1 equal to 0. If this will give 0, then simply like 4 it will give 0, 6 it is not going to give 0, it will give the 4 answer. It will give, it is giving the 4 if n equal to 6, if n equal to 4 it is giving 0, like if n equal to 8 it also gives 0. That's why if it gives 0 then return true, return just true. Yeah. Analyze the time complexity and space complexity. Time complexity is order of 1, actually it will give constant time complexity, and the space complexity is also constant. Sorry, that's no problem. Now calling the methods from the main method itself is power of 2k efficient. Sorry, no problem. Is power of 2 efficient. Yeah. Now running this like if we put 3, no power of 2. If we put 4 is a power of 2. If we give 16 it is the power of 2. It will, if we give 18 it's not the power of 2. That's it.